Thank you very much. I hope my screen is sharing. Welcome. Welcome to the Managing Feature Flags in a 280,000 line JavaScript code base. I pressed the wrong button. Let's try that again. Okay. So my name is David Burrowes. I'm currently a front-end software developer at Split Software. We make a feature flag product. Previously, I worked at Box Software, where I worked on a Node.js microservice framework in JavaScript. And before that, I worked at another company called Delphix, where I was a front-end developer, including working in things like ActionScript. Remember that? So if you have thought about using feature flags or use feature flags, you may have found that they can get difficult to integrate in your code base and manage in your code base. We have found that if you think about your code architecture differently and think about a different way of managing these feature flags, you can actually make the integration of feature flags into your code base surprisingly pleasant to use. So for my talk today, I'm going to start off, remind us all what a feature flag is, why they're useful, talk a little bit about how introducing them into your code base can be difficult, and then talk about a solution we've found that has made managing our own feature flags fairly easy. After that, there will be a period for questions and answers. So let's start talking about a feature flag. Why do you want to use them? You want to use them because you want to make some feature available. And how might you go about making a feature available? Well, one thing you might do is just decide, hey, making code changes is far too risky. We don't want to do that. Just don't introduce any new features. Tell your PM and go on about your day. Another option would be just to go ahead into your code base, remove the old code, add the new feature, roll it out, let everyone start using it, because everyone enjoys a new feature. Another option might be to take your code base, make a copy of it, put your new feature into that, and then deploy that to another URL and have people use that. Another variation might be to have both versions of your code in one code base, and then use something like a random number generator to decide who gets to see which version. Which of these do you suppose is the best pattern to use for releasing a new feature? Well, from a modern standpoint of using feature flags, none of these are a good answer. The first one is almost obviously a terrible way to go. You're going to get new features. Your company's going to go out of business. You're going to have a very boring life. The next option to just make your code change and release it. People do that, but it can be a bit of a disaster. We've seen some cases where that's happened lately, where people just roll out a new feature, hey, everyone use it, and it hasn't gone as well as they'd really hoped. Another problem with this approach is that if you've got a bug in the code you've rolled out, suddenly all your customers are using the buggy code, and you have to go through some sort of fire internally to go fix the code and get the change rolled out and tested. Not a very pleasant situation. A much more insidious problem is you roll out a new feature. Suppose it has an impact on your sales. How are you even going to know that your new feature caused an impact in sales? Maybe your feature rolled out at the exact same time a pandemic started happening, and you have no way of judging, is the reduction in sales because of the pandemic, or is it because of my feature? So that doesn't work really well either. You can take your code, as I said, make a copy, put it somewhere else, run another copy in parallel and have people use that. The downside to that is that it's cumbersome to do. You've got another code base to manage. And when people go visit that website, are you actually going to get real use cases there? It's really going to be hard to tell if you're getting actual normal uses there to judge whether your feature is good or not. Finally, we have this idea of putting both versions of your code in and using a random number generator to decide who gets to see that. The problem with this is you really have no control over who is going to get to see this feature. You might, for example, have a large customer paying you lots of money, and they've built training materials and run books around your product, and now some of their employees are seeing a random feature. They're not going to be happy with it. The company's not going to be happy with you. It's not a good path. In addition, you have no way to measure which of these versions is doing what, because a random number generator is happening on the client. You can't sit back and see which users are seeing which version of your feature, and you're kind of blind to whether this is actually a good feature or not. So if you want to make use of feature flags in a modern context, you want all of these things. You want to be able to deploy your multiple features in a single code base. You want to be able to do the release of the feature, that is, separate the deployment of the code from the release of the feature to your customers, and you want the releasing process to happen separately. So for example, you deploy your code, and then later on the PM will go and decide when to release a feature or not. You also want to control exactly who can see the feature. So you might want your beta users to see the new feature, or you might want your cutting edge customers to see the new feature. You might want the customer that asked for this to see the new feature, or you might just want to release it to like a small percentage of your customers. In all of these cases, you want to be able to measure exactly who is seeing which feature and what the results are. You want to be able to correlate if there's an engineering problem, like you've got exceptions happen in your code. You want to be able to correlate that with the feature and the users that are seeing that. You also want to be able to correlate your business metrics with your feature. So you've released a new feature, you want to be able to notice that there's a 10% decrease in your sales because of this feature, or a 10% increase because of this feature. So these are all the things you want out of a feature flagging system these days. So in summary here, your feature flag in your code is probably going to look something like this. You're going to ask some SDK, hey, given my feature flag and the current user, get me the value of the flag. And if it's on, show them one feature. And if it's off, show them the other. And then you want to be able to use some kind of a dashboard elsewhere to manage who can and cannot see that feature. So that's an introduction to feature flags. Now I'd like to talk a little bit about how we use them ourselves. So as I mentioned at the introduction, we have a 280,000 line JavaScript code base. There's something like 4,000 components in there. We've got hundreds of actions, hundreds of reducers. The code base is 5 years old, and we've got one great team building it. Within our code base, we have something like 35 feature flags. This number varies from time to time. There are new features constantly being added and new features being removed, so the number is constantly fluctuating. Many of these features are orthogonal. That is to say, we've got a feature over here in the application which has its feature flag, and we've got another feature over here with its own feature flag, and they don't have a whole lot of overlap. But we also certainly have places where we have multiple feature flags in the same place, where we end up with 3 or more variations of the UI at any given point in different stages of development. So here's an example. We had on the left here, we had a bit of UI before which allowed people to pick which columns in a table to show. This exists in several places in our UI. And after it was in there for a while, the designers looked at it and said, I'm not sure we need this apply button or this cancel button anymore. Let's just get rid of that and let's simplify the design some. So they designed a new version. Well, we didn't want to just change it and throw it out for all our customers. We do, as always, we want to control how this is being rolled out and pick who is going to get to see the new version initially so we can get early feedback. So we put this component in, put it behind a feature flag, and now when you flip the feature flag to the new version, you see that. With the old one, you see the other. Here's another example. We introduced a whole new feature which allowed you to approve a change. So you see on the left, there was the old UI for making a change. On the right is a new UI which has an approver section at the bottom to give more detail about who can approve this change. Another example here is we had this previous UI with 4 tabs. We introduced an entirely new tab with new features that are on the right. Again, all this behind a feature flag. What's maybe interesting here is that when I gathered these snapshots for these slides, I didn't go find some old version of the application to run it on. I just turned the feature flag on and off and took a snapshot on each side. So both of these features exist simultaneously in the code base quite happily. So let's move on to talk about implementation now. So as I said earlier, your inclination would be to start building a feature like this. You have some SDK, you say, get me the value of this feature flag for this user and show the new feature or the old feature based on the setting. Now, if you have done this in your code, you're going to find this starts to get really sort of hard to read. You end up with these conditionals all over the place, which bloat your code. So you end up with multiple versions of the same code in the same file. If this, else that. And if you're maintaining the code, modifying anything, you have to think about these two very, very distinct paths through the code simultaneously, which can be kind of a head twister. Removing these things can also be hard to do. It's tedious, and it doesn't give you a lot of confidence that you're doing the right thing, despite it seeming like a fairly mundane activity. Now, when we were doing this and we were running into these problems, saying we're not super happy with how we're managing these feature flags, it's getting to be sort of a drag in the code base, especially when you've got features coming in all the time and features being removed all the time. So we tried to figure out how to make this better. We did some things where moving that SDK call and putting that into Redux and pulling that into connected components. And that improved it some, but the fundamental discomfort was still there. So over time, we evolved to a new solution, which we're actually very happy with at this point. There are three parts to this solution. I'm going to go into these in a little more detail. The first is to talk about the architectural units of the code. The second is to talk about togglers. And the third is to talk about a file system structure. Put together, these give a very elegant solution to managing your feature flags. So let's first talk about the architectural units. Your code always is going to have some kind of architectural units. In a React code base, you're going to have components. When you have Redux in there, as we do, you're going to have actions and reducers. But whatever framework you're using, you're still going to end up with some kind of natural component out of that architectural design. So we began to realize, rather than thinking about feature flags being introduced on a sort of per line basis in a file, we instead started thinking about feature flags as wrapping up around individual components. And that begins to pull some of this sort of conditional stuff out of arbitrary places in code and puts it in a more natural, more easy to think about position in the code base. The second part of this was we introduced the notion of something called a toggler. So what I have on the screen right now, this is a very generic toggler. It toggles something, it takes a flag, a new thing, and an old thing. And when you call this, it returns a new thing, which will call either the new or the old, depending on what you set up. So let's talk about one of these concretely. This is an example of using a toggler for a component. So on this code here, you can see at the top of the screen, I'm bringing in the toggler engine. I'll talk about this in a moment. We bring in the name of our feature flag. We bring in the old version, the legacy version of the component, the new version, and then I pass this all to the component toggler, and I get back a new component. This being React, my new component is itself another function, which acts like a component as far as React is concerned. But when I go and call it, it's simply going to look at the feature flag and decide which subcomponent to render. Now let's talk about the toggler code itself. So this is the engine behind this. This code is slightly simplified, but it's basically the essence of the problem. So we have this function we talked about earlier, the component toggler. I handed the flag and the two versions of the component. Within it, I set up a very normal Redux connected component. I set up my map state to props function. It pulls features, there are a set of feature flags out of the Redux state, sets up a property called isFeatureOn, which will be set to on or off based on the value of the feature. I then call connect, pass it map state to props, as you normally would, and I call this other function, which returns a component. This function's up here. This component is a functional component. It takes two other components. It creates a new component. It creates a functional component here, which takes a property isFeatureOn and some other properties. And based on that feature flag, it returns either one component or the other. So this is fairly straightforward, I think, to follow. And you can see, I think it's pretty easy to see that action reducers can follow the same basic pattern. So for example, so for the third part of this, we have a file system structure. In this case, we've got a component. Inside of this directory, I've got a new component, the toggler we just looked at, and the old component. So the benefits of all this, the benefits here are that the code that is calling your component which is being toggled, that doesn't need to know anything about the feature flag. It just imports your new component and uses it. Beneath that, of course, is a toggler, which is toggling the code. But then each of the individual components, the new one, the old one, they also don't know that the flag is there. So my new component, the trivial component, my new component doesn't know about the feature flag. The toggler in the index file, that's where the feature flag lives. And when I look at the old component, it doesn't know anything about the feature flag either. A third benefit here is that now removing a feature flag and conversely adding a feature flag is trivial. So let's look at this directory structure again. So if I decided I don't want this feature flag anymore, I've now rolled this feature out, everyone's happy with it, or conversely, they hate it, I want to use the legacy version only. What I do is I move the component out, the one I want to keep out, I rename it to the new name, and then I delete the directory. At this point, again, because the calling component and the calling components don't know that the feature flag is there, I have now removed my feature flag in a completely automated way. I can write a script to do this. There is no code changes involved in the process. So to summarize here, this three-part observation about our code of wrapping your flags around architectural units rather than arbitrary lines of code, of centralizing all the feature flagging into a toggler, and then using a directory structure to manage this, the feature flagging, gives us an organization where the code is easy to read and understand and modify, because you're not having to do all the thinking about the feature flagness within the code. It makes it very easy to test. You can write your unit tests for all your components, and they are completely ignorant about the feature flag. And adding and removing feature flags is just a file system transformation, which again makes managing of these really easy. This pattern we've ended up with has been a team effort, and I just want to call out the rest of the team that has worked on this: Marcio, Manu, JC, Leandro, and Jake. And that is all I have to say. Thank you.
Thanks, David. That was very informative. Appreciate it. What are some of the challenges that you have faced in implementing the solutions that you have explained compared to other things you discussed before? Some things that kind of, kept you awake in the night.
Well, you're saying what sort of problems might we have run in with this new solution versus ones in the past? Yeah. Well, the biggest thing here is you have this instinct to want to go and wrap the feature around the smallest unit of code. Your instincts are sort of saying, I'm going to end up with duplicate code between the new and the old version, and so it's better for me to go and optimize this and put this at the individual sort of line level. And that's definitely understandable, but it actually tends to be a false optimization. It drags your productivity down by trying to optimize every line of code. In practice, in many cases, when you're adding a new feature, the new version and the old version are sitting side by side, and you're really not changing the old version very much. So the inclination to want to optimize and share code between your new and your old is a false benefit. But that's something you need to sort of constantly work against.
Very good. Thank you for that. I have a question here. How would this work with backend changes or without Redux?
So without Redux, then you just wouldn't do that with actions and reducers. You would need to do whatever other pattern you're using for managing your state. You'd want to wrap that in the same way. If you are, for example, injecting functions into your React code, for example, to call something in GraphQL, you'd probably want to identify those, make those a pattern, and then wrap the flag around that in kind of similar to what we're doing with actions here. For backend, I do kind of the same basic thing. I'd step back and say what are major units. It may be a class, or maybe you've got some unit that you're using bigger than a class, and I'd be wrapping the features around that, again, rather than individual lines.
Very good. I don't think we have any more questions. So thank you so much for your time.
Okay.
It's been a pleasure listening to you.
Thank you.
Actually, hang on a second.
Yes.
We just got one.
At the last minute. Excellent.
This is from Thomas. What exactly controls the toggle?
So in the examples I was giving, what's exactly controlling the toggle, let me see if I can go back to that, is our Redux store. Obviously, that's specific to React Redux, so you would want to do your own, you want to find your own pattern there. But if I can get back here fast enough, if we come back to the toggling code.
So there we go.
Yeah, so if you come back here in our map state to props, in a Redux world, I'm pulling the feature flags out of the Redux store. And we've actually set stuff up so the SDK gets the new flags, it pumps them into Redux, sort of outside of the React Redux system. And then if there's updates to the flags, it then goes and pushes those into Redux. So all the components are just pulling this out of Redux into a nice little map state to props here. Again, if you're not using Redux, you won't have that, but you're going to have some place where you're going to be keeping these flags centrally. And the key is just to get those back into wherever your toggler is. I hope that answered the question.
Let's see if Thomas has anything to say or follow up.
Okay.
Oh, he says thanks.
Great.
Thank you
Thomas.
again very much. Sorry, you were saying something.
I was just saying thank you to Thomas for the question.
Very good. Well, thank you so much, David. Appreciate it. Thank you all.
Happy to be here.
Very good.
Good luck with the rest of the conference.
We have about 5 more minutes, so we'll be back with the next speaker in about 5 minutes.